Good morning everyone, how's it going today? Welcome to this week's new video tutorial on software development and artificial intelligence. In this video we're going to be building a complete application with a graphical user interface, all of it coded in Python. Okay? The application deals with a dataset, then trains a machine learning algorithm and displays some predictions based on the input data as well as some chart to visualize the data as well. Okay, so by the end of this video you will have this application that you will be able to put in your portfolio and show it to potential employers and to your friends as well. So let me show you just real quick how this works. You have a sidebar right here with a lot of inputs, and the inputs are represented in a chart right here. So if I change something like here, you will see that my chart changes, okay? And also in real time, we are making a prediction using the logistic regression model that we're going to train in scikit-learn. So if I move something like here, you can see that the prediction changes from benign to malignant, for example. There you go. So I mean, the objective of this, the real world use case of an application like this would be to plug it to a cytology lab, a cancer research institute, where you can take some tissue from a breast and then take some measurements from it, input the measurements here, like either automatically from the machine or by hand, visualize these measurements to have an idea of what the cell cluster looks like, and then make a prediction based on these measurements to see whether the cell cluster is malignant or not. And yeah, it's pretty cool. Uses data visualization, machine learning, and a web application that you can deploy. Yeah, by the end of the video, we're also going to deploy it. So there you go. I am assuming that you know a little bit about how machine learning works and a little bit of familiarity with the logistic regression model. I am also assuming that you have the basics of Python, and I am going to use very, very little CSS, and it is not essential. So don't worry if you don't have a CSS background. And yeah, so make sure to stick to the end of the video so that you have this awesome project in your portfolio. All right, there we go. All right, so the first thing that we're going to do in order to build this application is to train the model, okay? But before we do that, actually, I just wanted to mention that if you want a written version of what we are doing right here, all with the snippets of code that I'm going to be using and the written explanation of everything, it is you can find it in my blog. Everything that you will find in this video is also written in this blog post. Including the code snippets, and also be sure to check it out if you want. All right, so back to this dataset. Of course, we need a dataset to train our model in order to be able to make a prediction. Okay, as you can see, we are trying to predict whether a cell cluster is benign or malicious given certain measurements that we're going to take from it. And that is exactly what we have in this dataset right here from the University of Wisconsin. It's a free dataset. I will also put the link in the description. And the dataset contains a lot of variables of a lot of measurements made to many different cell clusters. The measurements include, for example, the radius mean of the cells, the texture mean, perimeter mean, etc. And then it also contains a column with the diagnosis of the cell cluster. So if it is M, that means that the cell cluster turned out to be a malicious cell cluster. And if it is B, that means that the cell cluster turned out to be a benign cell cluster. This means that we can train a machine learning model that is going to take all of these variables as predictors, and it is going to predict whether or not the cell cluster is benign or malignant. So in order to build this machine learning model, we're going to download this dataset. I have already downloaded it, and I included it right here in my project, but be sure to unzip the file, and then I just renamed the file data.csv and then put it right here. And then once that is done, we are able to start training our model. If you want to better understand how machine learning works and how especially logistic regression works, I invite you to watch the video that I made about that specifically, because I used this same data set in that video. And I mean, here we're just going to be going through the cleaning and the model building super fast. I'm not going to be explaining a lot of the logistic regression part, so be sure to check that one if you have some questions about that. All right, so now it's time to actually start training our model. The data that we included right here actually comes by itself already pretty clean, so we're not going to be doing a lot of exploratory data analysis either. Also, that's in the other video. So I'm just going to go through the cleaning super quick. So let's get right into that. All right, so let's get right into it. The first thing that we're going to be doing is we're going to create our project folder. The project folder is called Streamlit app .cancer in my case, but Streamlit app cancer, sorry. And inside of it, we have a model folder and another folder called data. As I mentioned already, I already imported the data CSV that I downloaded from Kaggle right here. And this one right here is the model. This is the file where we're going to train the model. And this is also the place where we're going to clean the data and to test that the model is working correctly before exporting it. Once we export it, we're going to be able to create a new folder right here, which is going to be the app folder. And it is in that folder where we're going to be creating our Streamlit application. But for now, we'll have to first create a model that we're going to feed to our Streamlit application. So that's what we're going to do in this file right here. Right here, as you can see, I have this basic condition. What this does is it tests that this file is, it only executes what's inside of it if the file is being executed directly and not being imported. This is basically just standard convention thing to do in order to make your code a little bit more robust. That way you can be sure that the main content of your application is not being run accidentally when you import the file somewhere else, and it's only executed when you actually want to execute this file. So there you go. And now let's just start adding our data cleaning right here and our model building and all. So there we go. All right, so let's get right into it. The first thing that we're going to do is to import pandas as PD. That's basic. In case you don't have pandas installed, you're going to want to pip install pandas in your terminal. And once that's done, you should be able to use it like this. Now let's just import. Actually, what I'm going to do is I'm going to create a new function right here that is going to be called getCleanData. And then I'm just going to define it right here. Define getCleanData. There you go. And this one first is going to read the data file that we have right here. So we're going to do my data is going to be equal to pd.read CSV, and we're going to read inside of data, and we're going to read data.csv. There is something strange going here. I mean, like, I'm not like super, I don't have a lot of like super long experience in Python. So my intuition would be to actually go up the model, like the model folder and into data. But actually it seems to, in Python, you just have to run it from the root folder where you're running the application. So, all right, let's do it like that. And then we're going to be printing the head of the data, right? So let's do data.head to visualize it, and we're just going to return the data to see how it works. So there we go. Now if we click on enter on read, we should have our head right here. And now it's actually time to clean it. And to clean the data, I mean, you can do it by hand, like actually do an exploratory analysis on the data, and that is what you should do if this is a new data set. But that I have already worked with this data set and I know how it looks like, so I'm just going to clean it super fast so that we can go faster into building the application. Okay, so for example, I know that in my data I have this column right here called unnamed 32. And I know that I'm going to want to drop it because I know that it is all completely NaNs, okay? So let's first do that. I'm going to do data.drop. Data.drop. And I'm going to drop this one right here, which is called unnamed 32, like that. And then I'm going to say that it has to be dropped from axis 1. And then I am also going to drop the ID column, which I don't need either. And I'm actually going to drop it from here. ID, like that. There you go. And now the diagnosis variable, we have it that it uses M's and B's. And we're going to encode it so that malicious, I mean like M's, becomes 0. And benign becomes 1. No, benign becomes 0 and malicious becomes 1 because we want to test for malicious cells. So let's do that. So in order to do that, we're going to be using the map function and we're going to be targeting the diagnosis column right here. And this one is going to be diagnosis.map, and the map takes a dictionary, and in this dictionary, I mean, of course, it takes key value pairs, and in the key you have the actual value that you have currently, and in the pair you want to have the value that you want it replaced with. So malicious is going to be 1 and benign is going to be 0. There you go. Now we can print, I suppose that is the clean data. Let's just check that out right here. Print data.head. There we go. We save it, we run it, and now we have the data that is being run, and I mean the head of the data. We have the diagnosis, a lot of diagnosis of 1, and we have the factor. I mean, we don't seem to have the unnamed column. I'm just going to check it real quick using the info right here. So as you can see, we don't have an unnamed column, and we don't have the ID column anymore, and the diagnosis column is now 1s and 0s. So this is exactly what we wanted. So now, as you can see, we already have the clean data, and now we can actually train our model from this data. So what I'm going to do is I'm going to do create model. There you go, and I'm going to define create model up here. So let's do that right now. All right, there we go. So in order to actually create our model, we're going to first have to pass in the data right here. That's something that I forgot. The data that we just got from our clean data function right here, we're going to pass it right here. And inside of this function, what we're going to do first is we're going to divide the data into the predictors and the target variable. Okay, so my predictors are going to be called x, and I'm going to say data.drop, and I'm just going to drop my diagnosis right here. I'm going to do axis 1 to be sure that it's dropping the right part. There you go, like that. And for y, this one is basically just the diagnosis column. There you go. And now what we're going to want to do is we're going to scale the data first, because as you can see on this information from the data that we have. Some variables are much larger than the others, like for example this one's in the thousands and this one is just decimals, this one's in the hundreds. So in order for our model to actually have uniform data, it all has to be on the same scale. So that's what we're going to do now. And in order to do that, we're going to have to import the standard scaler from scikit-learn. Okay, so I'm going to do from sklearn.preprocessing. I'm going to import standard scaler. There you go. And now I'm going to be able to use it right here. So I'm going to say that my scaler is going to be equal to standard scaler, like that. And then we're going to basically just scale all of my training predictors, okay? Because of course the diagnosis doesn't need to be scaled because it's already either zeros or ones, okay? So my x is going to be equal to scalar, the scalar that I just created. I'm going to say fit transform x to scale my x predictors. There you go. So now we should have our scaled scalar. There you go. And our scale data. And now what we're going to want to do is we're going to split the data into testing and training set. Okay. Here, scale the data. I'm just going to comment it real quick. And then we're going to split the data super quick. There we go. And there we go. Now in order to split it, we're going to be using another library. It's going to come also from scikit-learn, but this library is called train test split. I suppose you already know it, but I'm going to import it like this right here. Model selection, import train test split. There you go. And now we can actually test split our data into training and testing set. So my X train, my X test, then we have my Y train, then we have my Y test. There you go, like that. And this is going to be equal to my train test split. And this one is going to take, first it's going to take my predictors, then my target variable. Then I'm going to say that the test size is going to be 20%. And I'm going to set a random state of 42 because that's the best number. And now that our data is split, we can actually train it. Now, as you can see, we already have this train, which is 80% of our training predictors, and this test, which is 20% of our predictors. And same with the diagnosis, the target variable. Okay. So now for the train model, we're going to do model equals logistic regression, but we have to first import logistic regression from scikit-learn as well. And from sklearn.linear model, we're going to import logistic regression like that. Then we're going to use it right here. There you go. And this is the model that we're going to export to use it in the Streamlit application later. Okay. So in order to be able to actually use it, we're going to have to fit it to our data. So we have X train and Y train. There you go. I'm going a little bit fast with this training model part because I'm assuming that you already have a little bit of knowledge on that. But if you don't, also remember to check the other video where I explained the logistic regression model and what is the intuition behind it. Okay, I go through this, but in much more detail. So there we go. And then finally, once we have it tested, once we have it trained, we're just going to return it. And we're going to return the model. And we're also, very important, we're going to return the scalar right here. This is going to be super important later because we're going to be using it to make our predictions later. Okay. So here that basically means that I'm exporting the model and also the scalar. There you go. Now that we have the model and the scalar, we can actually test the data. So let's see, we're going to test our model. And that also means that I'm going to have to create a new function right here for testing, okay? Test the model. So define test model. We're going to test the model. There you go. All right, so first of all, wait, just let me be sure that this is actually working. Does it run? Seems to be running correctly. Okay, we're going to be testing it in a moment anyways. So there we go. There we go. So now it is time to actually test the model to make sure that it's working correctly. And to do that, as I mentioned before, we have this test model function that we are creating right here. And let's just create the test. In order to actually run the tests, we're going to be using also another library from scikit-learn. I just wanted to mention that, of course, here we're using scikit-learn to build our machine learning model, because we're making a very simple prediction based off a very simple list of variables. But this actually works pretty much with any AI model, all right? So whether it be machine learning or deep learning, I mean, you can be running TensorFlow here and then build an application that makes prediction based on TensorFlow. So, I mean, the fact that I'm doing it with scikit-learn doesn't mean that you cannot plug in a neural network right here and make your predictions with that, okay? Just so, as long as you're able to export your model later, as you will see in a moment, it should be okay. So, we're going to test the model right now. To test the model, we're going to be using the predict function from the model that we just created and that we're importing right here. So let's do that. We're going to say that the y predictions, actually, you know what? We're just going to test the model inside of here so that we can actually have access to all of this. There we go. We're going to test the model right here. Train the model. Then we're going to test the model. And in order to test the model, we're going to create the predictions. Predict, the y predictions. And they are going to be based on the model right here. And we're going to run predict. And we're basically going to predict on the x test set, okay? As you remember, we trained it on the training part of the predictors, and now we're going to test it on the testing part of the predictors. And then, finally, we're going to print the accuracy of our model. And we're going to say that the accuracy is the accuracy score. But in order to use the accuracy score, we're going to need to import that function from scikit-learn. So from scikit-learn.metrics, we're going to import accuracy score, which basically tells you how often you were right in your predictions. And also we're going to import the classification report. There you go. So for the accuracy of our model, we're going to say that we're going to check the accuracy score. And this function takes two parameters. The first one is the actual values, and the second one is your predicted values for y. Okay. Remember that the actual values are stored right here in the test variable, and the predicted variables are the ones that we're predicting with our model. And this should print out the accuracy of our model. And second of all, we're also going to print our classification report, which is a more in-depth analysis, in-depth report of our model. So we're going to use the classification report. And just as the previous one, it takes the actual values for the actual values for the diagnosis and then our predictions. There you go. Oops. There we go. And then, just as before, we're going to be returning our model and our scalar. There you go. Now we should be able to run this, and let's see what it returns. Okay, so we have an accuracy of our model of 97%, which looks pretty good. And here's the classification report. We have a precision of 97% for for benign for benign cell clusters, and a precision of 98% for malicious cell clusters. We also have the other measures, other statistical measures right here, like the F1 score, which is very important if our data set is very if the portion of actual positive diagnosis is very little. So there we go. I mean, our model seems to be looking very good. Now it is time to actually export that model and the scalar, of course, very important, and to start using it in our application. There we go. All right, there we go. Now that our model script is pretty much ready, it should look something like this. Just minimize the function so that it's easier for you to see what is going on. But as you can see, we first created the clean data function that I just built super quick because I already know the data. But remember to perform some exploratory data analysis to make sure that your data is clean before actually using it. And then we created the model. Also, I did that super quick because I have already worked with this data set, but also this should be like a little bit of a longer process if this is a new data set for you. And then we exported the scalar and the model in order to be able to make our predictions in our application. Okay. And now what we're going to do is we're going to export the model and the scalar in order to be able to use them inside of our application. This is very important because sometimes you might be tempted to just run this code inside of your application. That would mean that it would be training a machine learning model inside your application every time someone opens the app, which is terrible for usability. I mean, it's just going to make your application way slower because every time it's going to be opened, it's going to be training an entire machine learning model. I mean, this one is quite fast because it's just a logistic regression model on on very little data. But like, anyways, it should be like something that you do systematically, that you build your model apart, and then you export it to a binary file, and then you import that binary file into your application. Okay, and that is exactly what we're going to be doing right now. In order to do that, you're going to want to install first this package called pickle5. So in order to do that, basically you just do pip install pickle5. It's the one that we're going to use for exporting our binary file. Then you're going to import it like this, import pickle5 as pickle. And then we're going to write a binary file with this module. Okay, so first we're going to open a new file. We're going to call it model.pickle. And then the second argument of the model, we're going to say that we're going to be writing in the file, and then it's a binary file. That's what the B stands for. And we're going to say as f for file. And with this file, we're going to pickle.dump, and we're going to dump our model inside the file. There you go. And then second, we're going to do the same thing with scalar. Scalar.pickle, like this. And just as before, we're going to say that we're going to be writing on it, and it's going to be in binary mode as file. There you go. And also we're going to pickle dump, but this time we're going to pickle dump our scalar. And we're going to dump it into our file right here. So there you go. Just as I mentioned before, even though we're running, this file is being executed inside of model, we want to save it inside of model itself. So we do model like that. That way the file is going to be, the binary for our model is going to be stored inside the model folder, and same for model for the pickle folder, right? So there you go. So there we go. Now, if we run this and we save this, we should be able to see that our model.pickle is being saved right here, but our scalar doesn't seem to be saved. So no such file or directory, says it. Right, open pickle scalar f. Maybe I have to change this here. Let's see if that works. No such file or directory. Model scalar.pickle. Oh, right, yeah, sure. I added just like an extra parenthesis right here. So yeah, the G was not a problem. There you go. Now if we save it, we should have our model.pickle and our scalar.pickle like that. There you go. And these are the files that we're going to be importing into our application. So now that our model is built and our scalar is built and both of these binaries are exported, it is time to actually start building our Streamlit application with this. Okay, so there we go. Let's get right into it. All right, so now it's time to actually create this app. In order to do that, as I mentioned before, we're going to create a folder called app, and inside of it, I'm just going to create another file called main.py. There you go. And it is in this file that we're going to be running the application. So just as before, we're going to be testing that this is the file that is being executed and not that it's being imported somewhere else. It's just like a safety mechanism. Then we're going to run main like this. There you go. And now we're going to have to define our main function, main, and we're going to say print hello world. We will build a Streamlit app. There we go. So now let's see how that looks. Hello world, we will build a Streamlit application. There we go. So let's do this. First of all, what we're going to want to do is we're going to want to import Streamlit, okay? And in order to do that, you are going to have Streamlit installed. Streamlit is a Python library that allows you to Streamlit. Streamlit is a Python library that allows you to build web applications super quick, basically around some data. It's super useful to create like dashboards or data visualization applications, or in this case, machine learning prediction applications. Okay, and it's super fast. You will see how we're going to start up this application with very few lines of code. So, as I mentioned before, you're going to have to install it. So you're going to do pip install Streamlit first. I already have it installed, so that's going to be super fast. But then once you have done that, you're going to have to come right here and do import Streamlit as st. what is going on here? That's st. There you go. Then we're going to do import pickle 5 as pickle, like that, in order to actually import our model and scalar. And we're going to import pandas as pd as well, in case we need it. So there we go. So in our main function, the first thing that we are going to do is we're going to set the page configuration for our application. So that goes st set page config, and here we're going to say that first we need the page title. You know what? I'm going to do it like this. Page title. It's going to be breast cancer predictor. There you go. The second argument that it takes is the page icon. I'm not sure, but I think it takes icons like this. So I'm going to say female doctor. It's supposed to work. And the layout, I'm going to say it's wide, because I mean, if I just run it like this, let me just show you. In order to write anything, I'm just going to say write, and let's just do hello world. There you go. If we save this file like this, and we try to run it, also watch out, in order to run this file, you cannot just do Python your app main.py, because this is not going to actually execute the application. In order to run the application, you're going to have to do Streamlit run, and then actually target the file that you want to run that has the Streamlit application, and then it's going to start up. It's going to start up this app in your browser. And as you can see, we have our app, and it says "Hello World," which is the text that we wrote right here. Okay, so just with that, we already have an application that is up and running. So that's pretty convenient. And now, as you can see, we have a contained layout. It has a container right here with a very big like margin, but we want it to be like a wide layout. So I'm just going to set right here that this is going to be layout, and the layout is going to be wide. There you go. And we are going to have a sidebar. So I'm going to say that the initial sidebar state is going to be expanded. This one takes expanded. There you go. Now if I save it and I rerun the application, you can see that the layout is wide, and I still don't have a sidebar because I haven't created it yet, but as soon as I add a sidebar, it's going to appear open right here. So let's get on to that. So there we go. That is pretty much the start for the Streamlit application. The next thing that we're going to do right now is we're going to create the layout of our app, create the sidebar, some columns, and then start populating the columns. Okay, so let's get right into it. There we go. So now what we're going to want to do is we're going to want to set a title for our app, and just write some explanation of it, and then just set the layout. Okay. Now I come from web development, so it kind of is a reflex to me to put everything inside containers, and Streamlit comes with containers that actually just become divs in the HTML code. Okay. So in order to create a container that is going to contain some other elements, you do st container like that. And in order to write inside of it, you can do with the default Python thing. And then whatever you write inside of here is going to be contained inside this container right here. And it's just a very convenient way to structure your application. So right here we're going to write st title, which basically creates a h1 header, and we're going to call it breast cancer predictor. There you go. And then we're going to stWrite, which basically creates a P element, which is a paragraph in the HTML. And I'm just going to copy this description right here from this file that I have on the side in order to not have to type it all. It's just a description of the application for the users and to make it easier for them to understand what is going on. And now that I have this container right here, the container includes the title and the P element. So let's just start the application again. And there you have it. You have our title, and then you have this quick explanation of the application. The explanation reads, please connect this app to the cytology lab to help diagnose breast cancer from your tissue sample. This app predicts using a machine learning model whether a breast mass is benign or malignant based on the measurements it receives from the cytosis laboratory. You can also update the measurements by hand. As you remember, we have this sliders that you can update by hand. But like ideally, for an application like this, you would want to plug it directly into the machine that is doing the measurement, so that you have the predictions immediately. All right. So there you go. Now that this looks correctly, we can continue with the layout. That was one container. Now we're going to create two columns. Okay. In the first column is going to be this chart right here, and in the second column is going to be this prediction box right here. So let's do that. In order to create columns in Streamlit, you can do st.columns. This is important because just a few months ago or years, I don't know, this was a beta function, so you had to do beta.columns, etc. But now that it's in the standard version, you can just do st.columns and it works. And this one takes takes a list of how many columns you want and the ratio of them. So I'm going to do 4 and 1, which means that the first column is going to be 4 times as big as the second one. And since we're creating 2 columns, this function returns 2 columns like this. Col1 and col2 equals st.columns 4 and 1. And then, just as we did with the container, we can write inside of these columns by using the width function from Python. So we do width column 1. We're going to do st.write. This is column 1, and then with col2, we're going to do stWrite, which remember creates a P element like a paragraph, and this is column 2. Remember that the first one is supposed to be 4 times as big as the second one, so let's see how it looks. Am I running it or not? There you go. So here, this is column 1 and this is column 2. As you can see, it's shorter than the column 1 by a ratio of 1 to 4. So there you go. That seems to be working correctly. Now what we're going to do is we're going to start with the sidebar. We're going to create our sidebar right here with all of our inputs. And then from those inputs, we're going to generate the chart and the prediction. So there we go. All right, so what we're going to be doing right now is to create our sidebar for our application. Okay, the sidebar should look something like this. And it has, as you can see right here, it has a slider for every single variable in our data. Okay, so here we have our data. And as you can see, we have around 30 predictors. If I remember, we dropped 2 columns. So we have 30 predictors. And so we should have 30 sliders, 1 for each predictor. And depending on the value here, we will make our prediction and we will update our chart right here. All right. So in order to do this, the first thing that you want to do is to subscribe to the channel and to like the video, because if you have come this far, that probably means that you're enjoying it, and it would be very good for me. Thank you. Alright, so now what we're going to do is we're going to create this thing right here. I'm just going to add it before the container. I'm going to make my own function where I'm going to actually create the sidebar. I'm going to show you a little bit later why I'm doing this. But let's see. The function is going to be called add sidebar, like this. And then I'm just going to create my function up here. Add sidebar. Define add sidebar. There you go. And now inside of here, in order to create a sidebar, all you have to do is do st sidebar, and then just create a heading for the sidebar. I'm going to say a header, sorry. I'm going to say that my header is going to be called cell nuclei measurements. There you go. Now if I save it and I come back to the app that we are developing, now refresh, here you have your sidebar. There you go. So, I mean, just a quick note, I don't remember if I mentioned this already, but, I mean, in this example, ideally you would want this data to come directly from the cytosis lab and to not have to update all of them by hand. But it's just an example, right? So, I mean, ideally you would have this plugged into a laboratory, and then the laboratory would fill the input values automatically based on the measurements from the machine. And then, like, the researcher would be able to just tweak some values to make sure that it's what they intend. So there you go. So now we're going to create this sliders right here. But here we're heading to a problem, and it's the fact that, as you can see inside of our app file, we don't actually have access to the column names or to the maximum values of the column names, because as you can see, each slider needs a maximum value so that we know kind of like where to stop this. And to, like, in order to not set a maximum value of 100 right here, if all the values will be between 1 and 10, right? That would be extremely complicated to choose a value if all the real values are actually just like on this portion of the slider. So what we're going to do, there are two things that we could do here. The more formal and correct way of doing this is to export an object, just like we did with the model and the scalar when we're training our model. Export an object with the information that we need, which would be the maximum value for each column, and the column labels and the column names, for example. Since we are doing this like super quick, and also since the data is very, very, very small, like our data set is just a few hundred lines long, so that means that we can probably get away with actually importing the data inside of the app. This is not what you would do in a real production application, but we're just going to do it right here to show you how it would work. Like, just keep in mind that in a real world scenario, you would do this in the main file and then just export it, just as we did with the pickle function, and import it right here. All right, so let's do that. I'm just going to create a function where we get the data. I'm actually just going to copy it from here. Get clean data, because remember that we want it clean. And now that we have the function of get clean data, we are going to call it right here inside the sidebar. I'm going to say data equals get clean data. There you go. And now what we want is the column names of the sidebar inside of a list, right? Because we're going to want to, and also we are going to need the labels of each of these sliders, right? Now I'm going to cheat a little bit right here because I had this ready. I asked ChatGPT to make it for me. So, I mean, that just makes it a little bit easier because otherwise I would have to type all of this by hand. But the idea here is that you have a list with the label right here and the name of the column right here. So this is the value that we're going to be using as a label for our slider right here. And and here's the column name that we're going to be using to actually access the maximum value of that column. Okay, so I mean, this is the same for every single column in our data set. I mean, you would probably want to find a better way of doing this, but since ChatGPT just does it super fast, I just asked it to do it. And then once we have that information, what we're going to do is we're going to loop through all of these labels and all of these column names, and to create one slider with each of them, right? So in order to do that, we're going to say that for the label and the key, which are the two values in my list, in this list, we are going to create st sidebar.slider. I'm just calling sidebar because we want the slider to be inside the sidebar, but we could very well just do st.slider. Okay, this is just to put the slider inside the sidebar. And the slider, we're going to say, we're going to say that for each element in this list, the slider is going to take the first argument that the slider takes is the label. And we're just going to set it to the label, which is this one. The first value in our value pairs. And actually, I'm just going to erase it like that. I'm just going to say label like that. It's pretty much the same thing. And then for the minimum value, we're going to set it to 0. And then for the maximum value, let's set it to 100. Just for now, just to show you what is happening. I'm going to save it, and right here let's just refresh, and there you go. You have around, I think it's 30 sliders that go from 0 to 100, and each one of them has the label that we require. So that's looking pretty good so far. Now actually let's just tweak it a little bit so that it actually is what we intend it to be. Now in here, instead of it being 100, we're going to make it take the maximum value in the column that we're in. So in order to do that, we're going to take the data that we previously imported, which is basically just the data set, and we're going to say that we're going to pass in the key. This is going to select the column in the data associated to the variable that we're using. So here in this case, for radius mean, it's going to take the column named radius mean, which is the column that contains the data about the radius mean. There you go. All right. So, and this one, we're going to take, the maximum value right here. There you go. And in order to make sure that everything's working correctly, we're going to convert it to a float. And if we save it right here, this is not going to work because this number right here is an integer and it should be a float as well in order for it to work. If I refresh this, we have the problem that it has the minimum value has an integer type and the maximum value has a float type. So in order to fix that, we just do float. There you go. Then we refresh this, and there you have it. Now the maximum value is like something that makes more sense for this given value. So in this case, as you can see, the area can go to 2500, and this one right here, the maximum goes to just 0.16. So I mean, that makes it way easier to actually visualize and to choose the real value for it. And now let's just set an average. I mean, like a default value, and we're going to set pretty much the same here as the same thing as we did here, but we're going to say that instead of the maximum, we're going to say that we're going to take the mean value of that column. Okay, we got a comma here, and then if I refresh, I should have the average value for each one of them. It's looking pretty good, huh? There you go. And now, one thing that you may want to consider is that this right here, actually, this function, the function slider returns the value of the slider. So we're going to want to save that somewhere in order to take that information and build our chart and our prediction, right? Just as a side note, here we're using sliders, but remember that you can use pretty much any HTML input element. So if I go to Streamlit inputs, here you have the input widgets that you can use. Here like a checkbox, a radio button, select box. Here we're using the slider, as you can see, st.slider. But like you can choose among any of these and use them to build your application, right? So there we go. Now, I was saying that this function right here returns the value for each one of these. So what we're going to want to do is we're going to create a dictionary, input dictionary, and we're going to say that for each one of this, we're going to create a new key value pair in the dictionary that is going to have, as a key, it's going to have the column name, and as a value, it's going to have the current value of the slider. So in this case, for example, it's 1413. That means that in our dictionary, the key value pair with the key of radius mean will have a value of 1413. And that is the dictionary that we're going to use to create the chart and the predictions later on. All right. So now we do that. And here what we're going to do is input dictionary. And we're going to say that here is the key. There you go. So this basically is doing what I told you, creating a key value pair. Well, the key is the name of the column and the value is the value that the user input in the slider. And then we're just going to return this dictionary, input dictionary, like that. And then we can retrieve the data right here. Input data will be equal to whatever the sidebar returns, and the sidebar is returning the data from those inputs. So now if we refresh, this seems to be working correctly. And whenever I do this, it should be updating the value of my input dictionary. So there you go. Now we have created our... let me see if I can show you this. Let's do an st.write. Can I write just input data? I don't know if I can do this. Let's see. Yeah, there you go. So like here, I'm just like, this is just for test, right? Every time I update this, you can see that this one is being updated. This one is being updated. Like what I'm doing here is I'm just outputting the data that comes from the sidebar. So now this is basically what we need, what I told you, the key value pairs, and we're going to be building our chart from this and our prediction later on from this as well. So there we go. Just going to remove that. There we go. So let's get to building these two parts. All right, so now it is time to complete our application with a chart right here that is going to take the values from our input elements that we have on the sidebar. Okay, we want a chart to look something like this. The chart is a radar chart. That's how it is called, and it has different values right here on the circumference. And it has different values here on the radiuses, right? Radii, yeah. And the idea is that you will have the perimeter, the texture, and the radius, and you will have 3 values for each one of this. You have the mean, the standard error, and the worst value for that one in the cell cluster. All right, something to keep in mind is that this are not the same column, all right? So how to put this in simple terms? So the mean radius is one column, the standard error for the radius is another column, and the worst value for the radius is another column. All right, so it's not one single column from which we're taking the mean, the worst value, and the standard error. They are different columns in our data set, and that's basically just how our data set arrived, so that's how we're working with it. So as you can see here, you can see it clearly here. You have the radius mean, you have the radius standard error, and then you have the radius worst value, which should be here. There you go. So basically what we're going to do is we're going to create this chart, and we're going to map the values from the mean, from the standard error, and from the worst part of the dataset into each part of these traces. Okay, so let's do that. In order to build this chart, we're going to be using a JavaScript library that has a Python module called Plotly. It's super powerful, and it makes interactive charts. Unlike, for example, Seaborn or Matplotlib, here you have like an interactive chart that you can play with. I'm not sure if this is working. Yeah, here you have an interactive chart that you can play with. I don't know what this is. What's going on here? Zoom. Yeah. I don't know, for some reason there is a bug here in my JavaScript, I suppose. Yeah, but I mean, the thing is that you can usually play with it. We should be able to do that in a moment. But yeah, I mean, it's a very nice library, and the documentation is right here. Okay. What we're going to be doing is we're going to be copying this example from the documentation, and we're going to be updating it with our own data. Okay. So let's do that. I'm just going to copy this. Well, first of all, I'm just going to add my function right here. Instead of the text, this is column 1. We're going to write get radar chart, and this is going to be a function that takes as an argument my input data that we are retrieving from the sidebar. Do you remember that we're getting the dictionary of values from the sidebar? And this is the dictionary of values that we are injecting into we're passing to our data chart as an argument. So let's now create the function get radar chart like this. And inside of it, we're going to actually just add the code that comes in the example of our documentation. Something to keep in mind is that you're going to have to install Plotly first. So in order to do that, it's very simple. You're just going to do pip install Plotly. I already have it installed, so I'm not going to do it. But once you do that, you're going to be able to import Plotly right here, like that. Using, just as in the example from the documentation, graph objects, which is a module of the Plotly library that gives you a higher level of customization in your charts. But something that you can do is also use if you're using Plotly for other things, you can use the express module, which allows you to make charts with predefined characteristics. With way less code. But since we want it a little bit more customized, we're going to go for this one, and we're going to just copy this example right here. Now that we have this right here, notice that here at the end they have fig.show. That basically just renders the Plotly chart in the page. But this is not where we're going to be using, because Streamlit uses its own function to incorporate Plotly elements into the application. So what we're going to do is, instead of doing fig.show, we're just going to return the figure like that. And right here, we're going to get that figure, which this function is going to return. And we're going to use this Streamlit function called st.plotly chart. There you go. And then we're just going to pass in the figure element that we got from the function. So now if we save this, we should have this chart in our page. Let's see if we refresh. Does it work? There seems to be a problem here. Radar chart takes 0 positional arguments. Okay, I forgot to add input data here. There you go. Now if I refresh, there you go. Now we have our radar chart. It's looking pretty good. Now what we want is it to actually take the real values that we want it to take. And in order to do that, it's actually very simple. Let me just show you what is going on in the chart. So here, as you can see, we have 5 different values that the traces can take: mechanical properties, processing cost, etc. Right? And these ones correspond to the categories list right here, and they correspond to the to the parameter theta. And this is basically just the values among the angular values, all right? And the R are the radial values. So I mean the distance from the center to the actual maximum value that each value has. All right, I hope it's clear. There you go. So here, for example, we have categories. The first element in the categories list is processing cost. And here the first element of this trace, which is product A, is 1. And here we have it, that it is the value for that one is 1 right here. And the processing cost is the value associated to it. Okay. Same thing, mechanical properties is the second one. And here it is number 5, the value for that one. So it maps to mechanical properties. And here we have it. It was 1 for processing cost and it is 5 for mechanical values. Okay. So all that we were going to want to do is we're going to replace this with our own values that are here, which come from radius, texture, perimeter, etc. And we're going to replace the R values with the values that come from our input data that comes from our sidebar. Okay, very simple. It might get a little tricky while we're doing this, but stay with me. It's not that hard. Just feel free to replay this part of the video if at some point you get stuck, or just ask me in the comments if you have any questions. Okay. All right. So what we're going to do is, first of all, we're going to replace the values on the perimeter with the actual values that we want. So let's do that. So we have processing cost here, and I have my list of values right here. Where is it? Here it is. And this is the list of values that I'm going to be using. There you go. We go from radius to texture, area, concavity, fractal dimension, etc. There you go. And now these are the categories, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values right here that we have to assign in each one of these traces. Okay. Forgot to mention what these two things are. This is basically just the name of the trace. Here it is product A and product B. And in our application, they are going to be mean, standard error, and worst. Okay. And the fill, it just tells Plotly that it wants the figure to be filled with color. Okay. So if I set this one to none, for example, we won't have a reddy color here, like a red color here. We'll just have like an empty space with the line around it. Okay. So there we go. So let's just complete it. Here we have the categories. And now let's use the data in our input data to complete the values inside of the chart. And the values come right here. And I'm going to say, nope, it's not. There you go. There you go. And right here, I'm just going to add the values. I already have them copied on the side, but I'm just going to start typing them here so that you get an idea of what they refer to. And then I'm just going to copy them from my code that I have on the side. The idea right here is that you're going to take the input data. And remember, what is input data? The input data is the value that we're getting inside the function. And the value that we're getting inside the function comes from the sidebar. And do you remember what the sidebar returns? The sidebar returns a dictionary, a key value pair, a dictionary of key value pairs. Remember that in the key, it has the name of the column, and in the value, it has the value of the sidebar. So what we want right here is to take the key that is associated to the mean value. Here, let's just update this one. Mean value. The key that's associated to the mean value of the radius. Okay, so it is the key that's associated to this slider right here. This is the one that is going to be mapped onto the radius part of the mean trace. Okay, stay with me. There we go. So here it's going to be radius mean, like that. The second one is going to be input data, and it's going to be texture mean. And what is the key of this value? Well, it's very easy. It comes from this array right here. The first one is radius mean, the second one is texture mean. So we're going to take that one, we're going to put it right here, like that. There you go. And like that, we're going to do like that for every single one of our input data for our input data that comes from our sidebar. That's about the mean, okay? Because remember that we have the mean, we have the standard error, and we have the worst value. So we're going to do that for all of them up until here, all right? So I have that right here. Let me just copy it and paste it here. There you go. So it's exactly what we were doing before. This is a list with all of our elements. There you go. The first one is the radius mean, texture mean, etc., all the way to fractal dimension mean. And this comes from the object that we exported from the sidebar. All right? The theta is the same categories. And there you go. Looking pretty good. Now, same thing for the second one. The second one is not going to be the mean value, it's going to be the standard error. And this one is going to take the values of this one, radius standard error, up until this one right here, okay? And it's basically just exactly the same thing as the previous one. We take the R value and we paste the input data like this. Here I'm just going to do like that. There you go. Here I'm going to add some spaces. There you go. Oops. Just make this a little bit more beautiful and easier to read. Input data, symmetry, standard error, and I'm missing fractal mean. Yep, I mean, which is not a mean. It's actually the standard error. So there you go. Here we have standard error like that and like that. There you go. So just as before, we have the input data for each one of this. And here, instead of targeting the first 10 one, we're going to target the second from the second 10 one, from the 11 to 20. That's those, which are the variables associated to the standard error. And we're going to do the same thing for the third trace, which is going to be the worst value for each one of these. And here it's going to say worst value. This is the name of the trace. And here, instead of radius SE, it's going to be radius worst. And the same for all of them. Just going to copy them from the side. Like this. There you go. So now we have radius worst, texture worst, all the way to fractal dimension worst. And these are going to map to our categories. Okay? So there we go. Now if we save this, we should have radar chart that looks a little bit correct, but it's not going to be correct yet. Yeah, the thing is that let's see, what if I do something like this? There seems to be an error here. Input data, everything seems to be falling on 0.4 for some reason. R, categories to self, worst value, the range, return figure, we're going to show the legend. What's going on here? What do we have here? We must have an error somewhere right here. Maybe we're adding too many values here. Fractal dimension, from radius to fractal dimension, 1, 2, 3, 10, 3, 2, 4, 6, 8, 10. That's 10. Alright, what's going on here? Maybe this shouldn't have space here. I don't think that's it. Let's see. No. Alright, give me a second. Alright, sorry about that. The error was this little thing right here, okay? So we were defining our categories, but we had this comma right here, so it didn't know what this was, but now that we remove it and that we leave it like that, it actually sees that every single one of these has a different is a different element from the list. Okay, so there we go. Now our radar chart is looking pretty decent. I mean, not yet, but it's getting closer to that. So there we go. We have different values for fractal dimension, concavity, etc. All right. So now what we're going to want to do is we're going to have to scale our values. Okay. And how do we scale them? So the thing is that here you have, for example, the perimeter can go from 0 to 188, which is a ridiculously high value compared to, for example, smoothness, which can only go to 0.16. What we are going to do is we're going to scale all of these values to get them between 0 and 1. That way we can have a range for our we can create a range for our radar chart, so that if it's 0 it's closer to here, and if it's 1 it's closer to here. Because I mean, if we set it to 1,000, for example, let's set it to 2,500. If we refresh this, I mean, it's going to be all right for the area value, which is in the thousands, but it's going to be too big for all of the others, right? So, like if I put this one here, I mean, it will be able to detect it, but let's just scale every single one of them between 0 and 1, okay? So let's do that right now. In order to do that, I'm just going to set the range to between 0 and 1. I'm going to scale all of the values so that they be between 0 and 1. To do that, let's create a new function that is going to be get scaled values. I suppose you can also, and this is going to take a dictionary, okay? Input dictionary. I suppose you can also use scikit-learn for this. I'm just going to do this by hand because, I don't know, it was just a little bit faster, but I suppose you can do it with scikit-learn as well. So what we're going to do to get the scaled values is we're going to get the data first. Get clean data. Remember, that is the function that we created before. And with this data, we're going to take also just the predictors. So to do that, we're going to drop the diagnosis part. Data.drop diagnosis, and we're going to drop it on axis 1, like that, if I'm not mistaken. And now we're going to create the scale dictionary, which is the one that we're going to return. Okay. And what we're going to do is that we are taking the input dictionary, right? So for the key and the value pairs inside the dictionary, input dictionary, and for the items, so that we are looping through the key value pairs, what we're going to do is we're going to say that the maximum value is going to be equal to x, and then the key for this element in the value, which, remember that we're dealing with the original dictionary of key value pairs that we were working with before. We're going to do max, and then the same thing, but for the minimum one. The minimum value is going to be equal to the minimum one, and then the scaled value, which is the one that is going to have like, all right, so this is a little bit more of mathematics, but basically we are taking the maximum value in the given column and the minimum value in the given column, and then we're getting the scaled value based off that, taking the value of the actual input minus the minimum value over the maximum value minus the minimum value. Not min value, min val, like that. And this is basically just going to give us a scaled value, a value between 0 and 1 for every single value in our input dictionary. Okay, I suppose you can also use scalar from scikit-learn, but I don't know, I just found it faster to do it this way. So now in the scale dictionary, we're just going to replace the key, the value of the key, which is this one, with our new scaled value. There you go. And then let's just return the scale dictionary like that. Okay. I hope I didn't lose you there. Basically, all that we're doing is taking, this function basically just takes the input dictionary with all the values from this input right here, and it looks in the data for the maximum and the minimum possible value for this one, and then it just performs some operations, this operation right here, which will always be between 0 and 1, okay? So the closer it is to the minimum value, the closer it will be to 0, and the closer it is to the maximum value of the same column, the closer it will be to 1. So this function will return an input a dictionary that looks exactly as the one that it's taking, but with values between 0 and 1, okay? And this is the one that we're going to be using right here in our array chart to treat our input data. So the input data is going to be equal to get scaled values of itself. And now it should, all of the data that came right here will be treated as values that are between 0 and 1. So let's see how this works. Now, if we refresh this, and remember that we have updated our range to be between 0 and 1, because now all of our values are going to be between 0 and 1, right? Now, if we refresh this, there you have it. Now, all of your values are going to be between 0 and 1. Even if it's 2500, if I get it to the maximum, it's just going to be 1. And if I get it to the minimum, it's just going to be 0. All right? So there you go. Now that we have scaled our values and our radar chart is ready, we are ready to pass to the prediction part of the application. So there we go. Good job to now. There we go. All right, so now it is time to create this prediction part in our application. Okay, I just wanted to mention that congratulations for making it up to here. This is quite a long project, so and you have done a lot of work so far. So great job, congratulations, and let's just finish this application so that we can deploy it and show it in your portfolio. All right. So what we're going to do now is we're going to build these predictions right here, and we're going to do that replacing this function right here with a function called add predictions, like that. There you go. And then we're just going to have to create the function up here. Add predictions. And this function is going to take the input data, right? Because we're going to make the predictions using the input data from the user. And that input data comes from here. There you go. So now the first thing that you're going to want to do is to import a model and a scalar that we exported before from when we were creating the model. Okay, do you remember that we are not training the model inside of the application, but we're just importing it, right? So let's do that. In order to do that, we're going to first import the model from Pickle. Remember that I had already imported Pickle up here. So we're going to do pickle.load, pickle.load, and we're going to do open and the location of our model, which is inside the model, and model.pickle. Model and model.pickle. There you go. And then we're just going to say that we're going to open it in read mode, and it's a binary file. Yeah, R is for read mode, and and B is for binary mode. There you go. And let's do the same thing for the scalar, okay? The scalar is also inside model, but it's called scalar.pickle. There we go. All right, so now what we're going to want to do is we're going to convert this input data dictionary, because remember that this is a dictionary with key value pairs. In the key is the name of the parameter, right? So radius mean, radius standard error, texture mean, texture standard error, and in the value is the actual value that the user input here, right? So what we're going to want to do is we're going to convert that into a single array with the values, right? And in order to do that, what we're going to do is we're going to use NumPy, all right? So let's just import NumPy as NP. There you go. And right here, we're going to say that the input array, and we're going to convert all the values from our input data dictionary into a NumPy array. Okay, so we're going to say NP array. We're going to select it as a list, the input data, and we're going to select only the values, right? Now, if we save this, let's see. Let's do an stwrite and just pass in this input array, all right? So right now we should be showing the input array of only the values of this one right here in our prediction side, okay? So let's see if that worked. Let's refresh, and there you go. You have this 30 values, and it's just an array with with all of this, with the values that we input, right? So if we change this one, for example, to 138, this one is going to change. There you go. You can see that it's reactive, right? And that is exactly what we want, because we want to make the predictions when updating the inputs, right? So what we're going to do, though, is to reshape it, because our model actually takes a two-dimensional array, not a single dimension array. So we're going to do reshape 1 minus 1 like this. Then if we refresh it, there you go. That's how it's supposed to look, right? It's supposed to have like every single variable is supposed to be one single column. Yeah, so there you go. Now, what we're going to want to do is scale it, because as you can see right now, the values are exactly what we set them here to. So, for example, this one is 1413, and this one is 14, 12.7, right? And we want all of them to be scaled with the same scalar that we used to create our model, because otherwise the model is not going to work. So let's scale them with the model that we just imported. That is why it was so important to create and to export the scalar with the model when we were on this spot. So let's scale it. In order to scale it, I'm going to say input array scaled, and I'm going to use my scalar that I just imported like this, scalar.transform, and I am going to say that I'm going to transform this input array right here. And now if I write this one instead of the other one, you can see that everything has a value of 0. And why is that? Good question. The thing is that remember that we set the default value of each one of our sliders to the mean value of the entire column. We did that up here, if I'm not mistaken. Sidebar. There you go. So we set the value of each one, the default value of each one of our sliders to the mean value of the column. So in the scalar, since what the scalar does is to take all of the values of the column, and if it's very high, make it closer to the mean, and if it's very low, bring it closer to the mean, and then put everything in the same scale, right? If that makes any sense. So what's happening basically is that since everything is in the mean, everything is at 0. But when we move something a little bit, let me just move the first one so that it's easier to see. I move it below the mean, then it's going to become negative. And if I move it above the mean, then it's going to become positive. Same with the second one, etc. Right? So if you only see zeros at the beginning, don't worry. That's completely normal, and that's how it's supposed to work. All right? So there we go. Now that we have this scaled values, we can actually feed them to our to our prediction model, to our model to make predictions. Sorry. So let's see. Now we can say that the prediction is going to be. We're going to use our model, and we're going to say predict. Just as we did when we were testing the model, we're just going to say predict, and we're going to pass in the input. Input array scaled. There you go. And now we can just export the prediction like that. There you go. Now we can, if we refresh it, you can see that the prediction is 0, which means that it is benign. But if we move something a little bit too high, then it's going to be 1, which is malicious. All right. So that's up to here. We are already using machine learning to make a prediction in the model, using our model, and to show it in the front end. Now let's just make it a little bit like user friendly. So instead of writing just a prediction, we're going to say that if the prediction, so the prediction is an array. So if the prediction, if the first and only element of the prediction is 0, we're going to st_right. And I have it right here. We're going to write, we're going to say benign, benign, and else we're going to say malicious. There you go. And now we don't need this part right here. Now if I refresh this, there you go, benign, and then if I up, then it is malicious. There you go, it's looking pretty good. And now let's just add another part right here, which is going to be the probability of it being benign or not, right? So we're going to do as well st_right. And we're going to say the probability of being benign is, and we're going to say that the model, and we're going to say predict probability, and we're going to say the input array scaled 0 and 0, because this one returns all right, so this one one second, so this right here, predict probability, returns an array with two elements. The first one is the probability of it being 0, and the second one is the probability of it being 1, if I'm not mistaken. And then we're going to do exactly the same for the second one, but instead of choosing the first element, which is the probability of it being benign, or it being 0, we're going to take the probability of it being 1, which is malicious. There you go. Then when we save it, we should be able to see what's going on here. There you go. So we have benign, probability of it being benign, 58%, and probability of it being malicious, 41%. It's looking pretty good. And now what we're going to do, I'm just going to add another line right here at the bottom, just to mention like clarification that this app is only intended to assist professionals in making a diagnosis, but should not be a substitute for a professional diagnosis. So there we go. Now if we save this, we can refresh it, and there you go. Now you have your application with this really nice column right here, which tells you if the cells are benign or malicious. So there you go. I'm just going to add a little subheader and header right here, just to make it a little bit more user friendly. So I'm going to say st subheader, and I'm going to say cell cluster prediction, and then I'm going to st_right the cell cluster, cluster is, and then there you go, cell cluster prediction. The cell cluster is benign, probability of it being benign, probability of it being malicious, and then just our little text right here. There you go. Now, there you have it. Now, I mean, your app could be finished right now. I'm just going to add a little bit of styles right here, but for what we have been doing so far, this should be like already you have a very good app that is working. I'm just going, in the next part of the video, I'm going to show you how to update a little bit these styles with some CSS. And yeah, and then I suppose we can deploy it. So there we go. Awesome. So now, just for the record, our application looks like this. It looks pretty complete, and the code looks something like this. Okay. So we have our main function where we set up the page configuration using the Streamlit configuration. Then we add the sidebar that returns the input data in a dictionary. Then inside a container, we added the title and some description of the application. Then we just added our two columns, one of which is 4 times as big as the second one. And then for the first column, we added a radar chart with this function right here. And we are displaying it using the Streamlit function plotly chart and not just showing it, right? And then for the second column, we're adding the predictions using the machine learning model and the scalar that we had previously created and that we exported using Pickle, right? Now, what we are going to do is kind of an optional part of the video, is to style it a little bit more with CSS, right? I know that Streamlit is not thought of in order to, I mean, it's not made to use CSS on it, but you can use, okay? It, unlike Dash, it's kind of a little bit more complicated to do it, but you can. So I'm just going to show you how to do it. But in general, if you're using Streamlit, try to stay close to the default styles from the framework, all right? So what we're going to do is we're going to create a new file. First, we're going to create a new folder called assets. And inside assets, we're going to create a file called style.css. For my fellow web developers, this is probably where things are starting to get familiar. So in order to actually just make some modifications, that's why I meant that this is probably not the way, like Streamlit is not thought, it's not made to do this, but you can see that we have, I can just check right here, inspect this element and try to find where my box is right here. So it seems to be this one, and I can just copy the class. There you go. I copy the class, then I use it to modify it, right? And basically what I'm going to do with this one is I'm just going to set a padding of 1 rem. As I mentioned, this is completely optional. You don't necessarily need to know CSS, but I mean, it helps. I'm just going to set a simple border radius. Border radius of half an rem. And finally, I am going to set a background color to this color that I have right here, which blends very well with the background. So let's see how that looks like so far. Well, of course, for now, we're not going to see anything because we haven't imported it into our file, okay? And in order to import it into the application, it's some sort of a hack, because it's not, I mean, as I mentioned, Streamlit is not made for this, but we are going to just hack around it a little bit to make it display to make it show our CSS, okay? And to do that, we're going to add the CSS as though it was a markdown file, okay? So right here under the page configuration, I'm going to say with open, and I'm going to open my file, which is inside assets, style.css, as f for file, and I'm going to say that I'm going to add some markdown. Okay, as I mentioned, this is a hack. It basically just imports the file into the website, and Streamlit thinks that this is a markdown file, but it actually contains CSS, and it's going to modify the style of the web application, but it's kind of not what it's intended to, with like this markdown function, right? And inside of here, we're going to add our style tags like this. And inside the style tags, we're going to add our file. And I'm going to say format. We're going to say the f.read to get the contents of our file. And then we're just going to say that unsafe allow HTML to be able to parse it as HTML. Okay. So there you go. This should, I think, make us Format, yeah, I mean, this should import our styles file as a markdown file, but not really, into our file. And it should update the style of this box right here, which has this class. So let's see if that worked. There you go. So it worked. We just added a little bit of padding and just changed a little bit some of these things. So to me, that looks pretty all right. And the second thing that I'm going to do, just to make it a little bit more complete, I'm going to add a few. I'm going to make this one right here turn to red when it's benign and green when it's benign and red when it's malicious. All right, so let's do that. In order to do that, we're going to have to modify the code that we added in the add predictions right here. So as you remember, we added benign and malicious depending on the prediction. But here we're going to wrap it in a span element, which is an HTML element. And we're going to give it a class of diagnosis benign. And then we're of course going to have to close the span. There you go. And if we save this like this actually, and we refresh, you can see that this span is actually not being parsed as part of the HTML. In order to make the HTML elements that we put into these strings to be passed, we need to add this other parameter right here, which says unsafe allow HTML, and set this one to true. This one is going to allow us to parse the HTML inside of it, and now if you see, benign is actually benign is actually inside a span with classes diagnosis and benign. So now we can target those classes in the CSS style sheet, right? And we're going to do pretty much the same thing for our malicious one. So let's copy this and let's paste it right here, diagnosis malicious. And let's just close the span. There you go. And now we can target that right here. So diagnosis is going to have it's going to have a color, a color of white. It's going to have a padding of 0.2 rems and 0.5. You know what? We're going to use EMs here, 0.5 REMs, because we're dealing with this kind of button. I don't remember how to call these things. And then we're going to say that the border radius is going to be 0.5 EMs. There you go. And now we're going to target the background depending on whether it has a class of malicious or benign. Okay, so let's say that diagnosis.benign is going to have a background color of this green that I have right here. I just looked up some nice looking green beforehand. And then the same thing, but for malicious, okay? And for malicious, I'm going to use this red color right here. 1 second, this red color right here. I also checked it out before. There we go. So malicious like that, benign like that, and my classes, they're supposed to be malicious and benign. There you go. So now if I refresh this, benign, there it is, should have a, benign should have a green background, and malicious, I forgot to add unsafe allow HTML here. Unsafe allowed HTML to true. There you go. Now if I refresh, benign has a green background, and malicious, what's going on here? Apparently they're showing both. What's going on here? Why are both being shown? It's only supposed to show one of them. What's going on here? Let's see. Refresh, benign, and oh yeah, sorry. Because I'm logging malicious here and benign by the side. So malicious right here, and then there you go, like that. Now it's going to work. Now if we refresh, there you go. Now you have benign in green, and if you turn into malicious, there you go. Sorry about that. So now you have benign in green and malicious in red, and you have the probabilities that are also being updated reactively. All right. So there you go. Now the application is pretty much complete, I would say. And of course you can play around and add some other CSS code, but I wouldn't recommend it. I mean, I just added some of it right here to make it look a little bit more user-friendly, and just like I figured that the colors red and green looked very good. There might be some options to do this in Streamlit by default, but since it was pretty easy to just do it with CSS. So there you go. I mean, I hope this, now you have like your final application. Congratulations, bravo. Now, I hope this was cool for you. Now, what we're going to do is we're going to deploy it so that you can share the link to a future employer or with your friends, and to show them what you built and to get a job that pays you hundreds of thousands of dollars. All right. So there you go. Let's do that. All right. Awesome. So the application is looking very good. Now we have this app that's looking like it works. It looks perfectly and all. Now you're going to want to deploy it in order to share a link, and then your employer can visit it and your friends can visit it, and you can just show off and feel very good about it. Okay. The idea is that we're going to be using a resource from, like a service from Streamlit, called Community Cloud. Okay, there are different ways to deploy to deploy a Streamlit application. As you can see, it's just a regular application, and you can deploy it in if you go to the documentation, you can see that they offer tutorials on how to deploy it with Docker, Kubernetes, and to any hosting that you want. But here we're going to be using Streamlit Community Cloud. It's the fastest and easiest way to do it, and it's free, so why not? So what we're going to do is we're going to go to streamlit.io/cloud, like that. And then we're going to sign up if you don't have an account, of course. And once you have signed up, you're going to be able to sign in and to see a dashboard that looks like this one. Okay. This was just some test that I had started a moment ago. Just delete this. Oops, not like that. Going to delete this. There you go. All right. So your dashboard is going to look something like that. Okay. What you're going to do right now is, first of all, you're going to have to connect your GitHub account. Okay. And once you have connected your GitHub account, you're going to want to create a new repository. In this case, I created a repository called Streamlit Cancer Predict. And once you have created that repository, that is what you're going to be using to deploy to Streamlit Cloud. Okay. So once you have done that, we're going to come right here to our application, and we're going to say git init. If you haven't been tracking your code, which is a very bad practice, by the way, sorry about that. And then just add everything, right? It's going to add everything, git commit, and we're going to say first commit and first commit and finish app. Terrible way to make a commit, but there you go. So now we have our app that is already tracked in Git. It's like the repository is complete. Now we have to upload it here. What we're going to do is we're going to copy this one right here. I'm going to add it to my Git remote at origin, if I'm not mistaken, to add an origin for this one. I'm just going to paste the URL. And now, if I'm not mistaken, I should have it right here. There you go. Now, what I want to do is I'm going to push it to my remote repository in GitHub, right? What we're doing here is basically just push everything right here to GitHub. So we're going to do git push u origin main. And now, if we refresh this, our GitHub should have all our files. Good. So there we go. Now, what we're going to have to do before actually deploying to Streamlit is we're going to have to tell our application what are the modules and the packages that we're using, right? Because remember that while developing our application, we used several packages. So we used Pickle, we used Pandas, we used Plotly, we used NumPy. And what Streamlit Cloud does is it creates a virtualized server, and once it's virtualized, it doesn't necessarily have all these packages installed. So we're going to have to tell it which packages you're going to need. If you come from JavaScript, this is exactly the same as creating an npm package.json, right? So in order to create our package.json or our list of dependencies, we're going to need a new dependency from Python called piprec. Okay, so in order to do that, we're going to have to install it first. We're going to do pip install piprec, if I'm not mistaken. There you go. And then in the origin of our file, we're just going to do piprec, and then usually you would write where you want your file to be, but here I'm just going to say piprec, and it didn't work. Piprec is probably piprec. Let's see, does that work? What's going on? One second. Check. Let's see. What you're going to want to do. Oh, sorry, it's not piprec, it's piprex. Yeah, sorry about that. It's piprex with an S. So there you go. Now I have to install this one, and then I do piprex with an S. There you go. And now you have your requirements.txt right here. There you go. Now, as you can see, this is a file that basically includes all of your dependencies, I mean the packages that you installed, so that Streamlit Cloud can install them in their own server, and so that your application is able to run. Okay, so now that we have this, we're going to have to git add our requirements, requirements.txt. All right, so I already added it, so that's all right. And then we're going to have to commit it, add requirements, and that git push to our origin main. And now we should have our requirements right here. There you go. So that should be enough to tell our Streamlit Cloud service that we want to deploy using these requirements. So now we go to our dashboard. That's here. We click on New App. Remember to link your GitHub account. And then you're going to say which is the repository that you're going to want to deploy it from, which is the one that we just created, Streamlit Cancer Predict. The branch is the main branch that we're using, and the file, the path to the file. Okay. Here it already detected that it's inside app and main, which is app and main, which is this file that we're going to want to execute to load our application. And now We can click on, let's see, do we have advanced settings? I mean, you can set up secrets if you need to, but I didn't add any, so we can just deploy. And it sometimes takes a little while because it needs to install all the dependencies and just to get your app up and running. But it usually works very well. And now, as you can see, we have deployed our application super quick. Hopefully there will be no errors. So if you got all the way to here, thank you very much and congratulations. You have completed a very, very long course, and you know now how to create Streamlit applications that make predictions with a machine learning model, and you learned how to export that model that you created in Python and how to export it with Pickle, how to import it to your application, and how to use that to take some input from your user and to make predictions based on that input. And we also learned how to make a pretty sophisticated chart from the input that the user gives, and to update the chart reactively. So I would say that you have done an amazing job. So congratulations. And now here you go. Now your application is up and running, and it's in the web. So you can just copy this URL and share it with your friends, with your employers, and to show how amazing your skills are at machine learning and at creating web applications using machine learning technologies. Okay. As a reminder that you can use pretty much any machine learning, any model. It doesn't have to be like a logistic regression, which is super simple. You can be loading a neural network behind it, and it will totally work. So there you go. I hope you found it useful. I hope that you learned a lot, and be sure to subscribe for more videos like this, and be sure to leave a like, and don't forget to write a comment as well if you liked it, and to tell me if you had any questions. Also, if you find a comment that you know the answer to of someone, if you see someone asking a question and you know the answer to that question, don't hesitate to answer. It's a good way to learn when you explain what is going on. So thank you very much again for watching, and I will see you in the next one.